looking at this next problem, they're asking us to simplify. Now, first step would be, can you substitute anything in, right? And in this case, we can't, because we don't have anything in the form of a trig function squared plus or minus 1 or vice versa. And we can't cancel anything out, we can't split anything out, because we have two terms at the denominator on both fractions. But if you notice, they're kind of opposite of each other, right? And so that indicates that I'm going to try to put these equations, or sorry, these expressions, these fractions together. And in order for me to add fractions, they need to have the same denominator, which they currently don't. And so to do that, to get them to have the same denominator, I'm going to multiply the left expression by the denominator on the right. So secant x minus 1, numerator and denominator. And the expression on the right, I'm going to multiply by the denominator on the left, right? So I'm going to multiply the numerator and the denominator by secant x plus 1 in the numerator, and secant x plus 1 in the denominator. Now, before we continue, remember, there's more than one way to do this. You don't have to do it this way. There's more than one way to do this. So let's keep going. In the numerator, I'm going to go ahead and distribute this cosine to both of these in here. Multiply cosine to both of those in there. So it's going to get lengthy, and hopefully some things will cancel out, or we can make it smaller or simplify. So let's start. So we have secant x cosine x, and then we have minus 1 times cosine x, and then we have a big plus here in the middle. So we have a big plus between the two expressions, and we have again secant x times cosine x plus cosine x, and all of that is being divided by the denominators after we multiply them together. So when we multiply them together, those are the factors of a perfect square. And so when I multiply them together, I end up with secant squared x minus 1 squared is still just minus 1. And so notice how in the a negative cosine and a positive cosine, and we can put this together. And then we also have a secant cosine and another secant cosine, and we can put those two together. So let's get going. So the cosines cancel, and I have 2 secant x cosine x, and then in the denominator I have secant squared x minus 1. Now it kind of looks like it might be an identity, and so I start secant x plus cosine x squared equals 1. Remember, that's the original Pythagorean identity. So secant is 1 over cosine, so I'm going to divide everything by cosine squared, and I'm going to go ahead and divide and see what identity I get. So sine over cosine is tan squared x. That's a 1, and then this is secant squared x. Now you notice in the denominator here, I have secant squared x minus 1. Now I can kind of get that here by subtracting 1 on both sides, and I get secant squared x minus 1, which is exactly what I have. So I'm going to go ahead and replace that. But before we continue, we're going to do two things at once, right? And again, it doesn't have to be this way, but you can do it as you wish. So notice how in the numerator I have secant and I have cosine. So I'm going to rewrite that as 2 times 1 over cosine x times cosine x over, now we said secant squared x minus 1 was the same thing as tan squared x. In the numerators, the cosines cancel, and I'm left with 1 in the denominator of the numerator, but that's 1, and 1 over 1 is 1. So really I have 2 over tan squared x, and that's the same thing as saying 2 times cotan squared x.